Today we're going to be working on section 6.5, which is really similar to 6.4. Sort of the bell there going off. As a review, and statements were here. Okay, this is an and statement, and that means that the value we're looking for can be any number that's between 2 and 8. So like 4, 7, 6.3, something like that would be a solution to this and statement. Today we're going to be working with OR though, and that's a little bit different. So with an OR, we don't have the algebraic, writing and stuff like that. One sec. All right, and what this means here is pretty simply that you have to be a solution to one of these two statements. OR implies not both, okay, and does. So we're going to solve them each individually, or in this case, graph them each individually. So this one here, we have a 3, okay, and it's an open circle, and we're going to be shading to the left, which means that any number below 3 will be a solution to this. Also, if we have a 6, and we're going to be shading to the right, that means any number that's bigger than 6. So every number will be a solution except the numbers that are in between here. So any number that's 3, 6, or anything in between will not be a solution. Everything else will. So if we have equations here, we solve them totally independently of each other. So I can go -1 here and get 3x is less than 3. Divide by 3. And I get x is less than 1. So I am done with that first part. Over here I can add 5 and get 2x is greater than 12. Divide by 2. And I have x is greater than 6. So now the solving part is done. I just need to graph them. So we have x is less than 1, so I'm going to shade this way. And x is greater than 6, so I'm going to shade this way. And since it's not an and statement, it's an or statement, okay, we're done. We don't have to write an algebraic solution or anything else. So what this means is to make these statements true, okay, you need to be either less than 1 or you need to be greater than 6. Not both, because it's impossible to be both. Okay, another one, let's take a look at. So I'm going to add 3. So I get 4x is less than 9. I divide by 4. And so I get x is less than 9/4, or I know 9/4 would be 2.25 because 8/4 is 2, so it'd be 2 1/4 or 2.25. Here, I'm going to subtract 3. So I get -3x is less than 6. I divide by -3. Oh, I divided by a negative number, so I have to flip the sign. So there's our two statements. My graph is hiding down here. So this one we'll do first. 2.25 will be about here, and it's got to be less than that. So I'm going to shade this way. And it's going to be greater than -2, so I'm going to shade this way. Now here's an issue. I'm going to shade this one in green. So it can be anything over here, and I'll shade the other one in blue. This one can be anything here. So an OR statement says that it has to be one or the other. Well, if we look, one or the other covers everything. So therefore, it's going to be all numbers, okay, or all real numbers, okay, or just every number, or every real number could be a solution to this. Okay, those don't happen very often, but they definitely can. I'd like you to try this one on your own. All right, let's see how we did. -3, so we get 2x is less than or equal to -2, and we divide by 2. Now, even though this is negative here, this isn't, so we don't flip the sign. X is less than or equal to -1. And here we're going to add 5. So we get 3x is greater than 6 divided by 3. So x is greater than 2. Hopefully I have a graph. There we go. So this one, we are less than or equal to -1, so we have to shade in this, and we're going to shade this way. And this one, we're greater than 2, so we're going to shade this way. So every number is a solution except the numbers in between -1 and 2 and including 2. Okay? Last one, here we go. A baseball is hit straight up into the air. Its initial velocity, or speed, is 64 feet per second. Its velocity, or speed, is given by the following equation. V equals -32t, where t is time, plus 64. And I want you to create a table from 0 to 4 seconds. This is something a little bit review. So give it a try and see what you can do. Alrighty. So if I made a table, here's my t, and there's my velocity, or speed. So I have 0, 1, 2, 3, and 4. This here is 64, so it's got 64 feet per second right when it gets hit. This one ends up being 32. 0, which means that after 2 seconds, it goes up, and now it's stopped at 2 seconds, and now it's going to start coming back down. So then this one would be -32, or which means it's traveling down, and -64. Important that this is your starting speed, or 64, and this is our change or critical point, because that's when it stops moving and it starts to come back down. So those are important. All right, if you have any questions over this stuff, please let me know. The assignment's posted online.